Hello, this is Yokogawa Advanced Solutions. Today I'm going to introduce to you a high-performance operation solutions to improve human factors. When we think about plant safety and reliability, human factors are one of the most important issues. This chart shows 42% of unscheduled shutdowns or slowdowns were caused by people. And that is more than both process and equipment issues. Yokogawa has been providing consulting services and solutions under high-performance operation concept to achieve safe, reliable, and efficient production. It also includes an improvement of human factors for the plant operators. This video is going to present three major high-performance operations solutions to improve human factors. These are alarm management, ergonomic HMI design, and procedural automation. The solutions enable operators to make operational decisions quickly and correctly whilst maintaining a safe, reliable, and efficient operation. This slide shows the flow of an operator's mental and physical activities for decision making. An operator perceives an input from the process, interprets it, and then reacts. However, there are several disturbances bringing difficulties here, such as alarm flooding, scattered information, and insufficient guidance. Those difficulties cause stress to the operator and would lead to misoperation. To avoid such a misoperation and to improve operation reliability, an operator training program is often carried out. However, it seems not so effective because core operational skills are still only kept within the operator's mind. This unfortunately makes it difficult to transfer that knowledge to other operators. So Yokogawa proposes three HPO solutions to improve human factors. These solutions incorporate operator skills into the control system and help the operator perform like the skillful operator is always beside them. The first solution is our alarm rationalization consulting service. With the use of the Consolidated Alarm Management Software, CAMS, the consulting service supports your alarm management activities and enables a high-performance alarm system so your operators will feel that the alarms are always useful and effective. The second solution is AOG, Advanced Operating Graphics, a consulting service for ergonomic HMI design. AOG provides high-performance human-machine interface design through an ergonomic and operations task study. The final solution is MPA, Modular Procedural Automation, an ISA 106 consulting service for procedural automation design. MPA standardizes, advises, and automates your existing manual operations. Our powerful flowchart programming tool, Exapilot, has rich interactive functions to enhance the operator's experience. Therefore, MPA can automate such interactive procedures which was difficult to automate before. Each solution can be introduced individually to improve a specific issue, or you can choose a comprehensive approach to introduce all three solutions. Based upon our past experience, Yokogawa would recommend the following order. Alarm rationalization is recommended first because alarming is vital to notify the operator of malfunctions. Advanced operating graphics comes next because alarms displaying on a graphic screen would not be useful without proper alarm rationalization. Once the base operations are clear to the operator, finally we focus on the unsteady state changes, such as grade change with modular procedural automation. Now let's go on to the demos. You can see many alarms on the alarm summary display. In such continuous alarming condition, the operator may overlook important alarms, and it is hard to identify an alarm's root cause. This must hurt plant safety and reliability. Now we're going to implement FNAR, Fundamental Nuisance Alarm Reduction, the first step in our alarm rationalization methodology. We first focus on checking the current alarm KPI based on the EMUA 191 guideline. The result in this case was 62 alarms. It is characterized as reactive. We then identify the nuisance alarms that are causing the continuous alarming and analyze those for the root causes and countermeasures. A broad range of knowledge is required for this analysis, such as process engineering, operations, instrumentation and control, and maintenance. We check the KPI again after the countermeasures have been applied. As a result of this service, we can now only see 3 alarms. This is characterized as level 3, stable. Here is the alarm summary display after the improvement. Nuisance alarms were reduced to a level where operators can easily manage and understand the root cause of those alarms. The next step of alarm rationalization is EASD, EMUA 191 based alarm system design. FNAR was like a quick hack, mostly focused on steady condition, so we didn't touch the alarm design itself. However, in order to let the operator take effective actions, even if the situation is unstable, the alarm design itself needs to be reviewed. Using an extended hazard study method, we find out the required alarms for each hazard, as well as their safeguards, which is the focus in a traditional hazard study. But we also extend this out to review the alarm attributes, alarm priorities, colors, and guidance messages and other associated elements. By doing this, the system can provide operators with properly prioritized alarms, so when there is an abnormal event, they have the guidance to identify its root cause. Now, alarm rationalization is completed. The number of alarms are at a manageable level, with only the necessary alarms being generated in the proper order. Now let me show you how CAMS is effective during an unstable condition by simulating a malfunction and seeing what happens. Some alarms occurred on the side reflux of the distillation column. Some issues must have occurred in this area. You may also find the side reflux is showing 0. This time we're going to focus on alarms related to the distillation column. The CAMS filtering function makes this very easy. Let's filter process, then column. Now you can see alarms only related to the distillation column. Let's scroll down the alarm and event message area. We then find a pump trip has happened first, so the operator can easily find troubles like this. The operator will then ask a field staff member to check the pump and take the necessary action so the trouble does not spread throughout the facility. Now let's go into the AOG, Advanced Operating Graphics demonstration. This is an example of AOG. Different from conventional graphics, it is designed with the knowledge of experienced operations staff. This ensures a focus on ergonomics, such as proper color scheme, with the optimal layout. Thus, it becomes legible, easy on your eyes, and relevant for the operator. Within AOG, we implemented a design philosophy based around a 4-level hierarchy. The first level is focused on production KPIs, which the operator should maintain, such as production rate, quality limits, and regulation limits. The second level is designed around particular operation tasks, such as regular monitoring operations, unit startup, and so on. Level 3 is really the detail, showing the process flow of how things are interrelated and the individual transmitters. By the time we get to level 4, we're really focusing on package equipment. These levels have been around for quite a long time, but in Yokogawa we've given specific, clear roles for each level. This example was designed for monitoring and operation of a crude distillation unit. The key points were picked up through the feed selection to the rundown section and compiled into one graphic. The knowledge of skillful operators are incorporated into the graphic design. Data expressions are carefully selected for intuitive recognition, such as radar charts in the crude heater and the temperature profile of the distillation column. In the upper right corner of the screen, you can see the global map. This shows the operator a quick overview of the whole facility or his area and any alarms or alerts that he needs to react to. Now let me simulate a malfunction and see what displays on the global map. Now you can see an alarm sign on the global map. The operator can call up a graphic which contains the alarms by one click. Some alarms have occurred at the side reflux of the distillation column. Alarming points are displayed clearly due to the ergonomic design. Let me switch this graphic to a conventional design graphic. Now you can clearly see the difference between the AOG design and the conventional graphic design. I'm sure you can now see how much easier it is to identify any alarms or issues. Now that the base operations have been improved, let's focus on modular procedural automation. This would be an example of a safe parking procedure or a turndown operation to bring the CDU to minimum load. When a malfunction of process equipment happens, the safe parking procedure is performed to bring a process unit to the stable condition waiting for equipment recovery. A typical turndown operation is performed by rapid manual interventions and monitoring of important checkpoints during this critical transition. However, there are risks with this procedure, such as misoperation and the oversight of important checkpoints due to the complexity and length of the procedure. MPA is going to implement procedural automation to reduce the operator's burden and allow the operator to keep watching on the important tasks and checkpoints. This is a graphic showing the crude distillation column. Some alarms have occurred at the side reflux of the distillation column due to a tripped pump. You may find yellow buttons at the bottom of the graphic. By clicking the left button, you can initiate an automatic turn-down operation. Let me initiate this automated procedure. Please pay attention to the radar chart of the crude heater. You can see the decline of the feed rate while the temperature balance of the heater remains the same. In this automated procedure, the equipment was operated with the mass balance calculation instead of the operator manual controls. This procedure is configured with easy-to-understand flowchart style programming tools. Actually, let me show you the details. We can develop sequential procedures easily with a user-friendly graphical interface. Here we have included smart alarms to suppress the nuisance alarms that do occur during the unsteady state as we transition to the safe park. Therefore, the operator can concentrate on the important points, such as the temperature balance during the transition, and the operator can also spend more time to check the root cause of that tripped pump, and thus informing the parties that may be concerned, so that they can dispatch maintenance teams with sufficient lead time. This demo concludes here. We presented three major HPO solutions: to improve your human factors. First is alarm rationalization, advanced operating graphics, and modular procedural automation. We believe these HPO solutions help keep your facility safe, reliable, and with efficient operations. Thank you.